I know, she can stay out there. All right. What this means is it's really just y equals mx plus b, but b is 0. So if you write this, y equals mx plus 0, would you normally write plus 0 in an equation? No. So it's really just this, y equals mx. That's direct variation. That's it. When the b is always 0, I'm going to put dv here. Direct variation is that equation. So what you have to look for is that the b is 0. So let's look at a couple examples. If you have this, y equals 2x plus 0, yeah.
Would it just go right through the middle of the graph?
We're getting to that. You're ahead of me. Yes, it would. Okay, I wouldn't really necessarily write this like this. I would just write y equals 2x. That is a direct variation equation right there. And I'm just going to cross this off with orange because I really wouldn't write it like that. I would write it like that. That's a direct variation equation. The b is 0. What if I had this? Y equals 1/2 x. Is that a direct variation equation? Yeah, because b is 0. B is 0.
So all the other ones that we did were just like y equals or x equals, those were direct.
I'll show you. Stay with me. Is this a direct variation equation? Why not? Because b is -3. Okay, so this is not direct variation, not dv, because of this. It's not dv because of that -3. Has to be 0. So, I want you to highlight this. The book uses y equals ax, but it's the same as y equals mx. They just use a for direct variation. It's still the slope. Doesn't matter. And as Chuck said earlier, the graph of these always go through the origin. So let me just show you. Nope, don't want that. Y equals. Okay, which one of these is direct variation? The second one. How do you know that? Let's look at the graph then. Which one is direct variation?
The one that's going down.
This one is going down. It goes through 0. Always, always, always will go through the origin. Okay? Because the y-intercept is 0. So if you draw a little x and y axis here, your direct variation equations are always going to go through 0. Always, always, always. Always go through 0. Okay? All right. The constant of variation, it's the slope in these equations. Y equals a of x is the same as y equals mx. So I want you to highlight this too. The constant of variation. You're going to see that word in your homework, constant of variation. It's the slope. It's the a, so highlight the a as well. That's it, right there. So if you have this equation, the a, or the constant of variation, is 2. If you have this equation, the a, or the constant of variation, is -3/2. Can you read that? -3/2. Yep, -3/2. Where are these graphs going to hit the y-axis at? These two graphs, where are they going to hit the y-axis? 0. They're direct variation. Okay? They would hit the y-axis here at 0. All right, so the first thing you're going to have to do on your homework is tell whether the equation represents direct variation. If so, identify the constant of variation, or the a. Identify the a. So what I have to do is I have to solve for y. Put in y equals mx plus b form and see if there is a b or not. No b is direct variation. I put a little note to yourself there, okay? So I'm going to solve for y. Right here, the first thing I do is subtract 4x. Subtract 4x. These go away. I have 5y equals negative 4x. Divide by 5. Divide by 5. I get y equals negative 4/5 x. Is this direct variation? Yes, why? Because there's no b. So I'm going to say yes. And the a equals what? Negative 4/5. The a is negative 4/5. Okay, here we got to get y by itself. So the first thing I'm going to do is subtract 2x. Subtract 2x. I have negative y equals negative 2x plus 3. Where am I going with this? Can I stop right now? How do I know it's not direct variation already? Because you have this plus 3. So you just say no. You can stop right there. Add x, y equals x plus 1. Is that direct variation?
No.
What if it was written like this? What would you say? Still no. Still no. It has a y-intercept. It's just, these just is flipped around. Doesn't matter. If this wasn't here, then it would be direct variation. If that wasn't there, it would be direct variation. Okay? So no. All right, and then this one, I'm going to subtract 2x from both sides. I get y equals negative 2x. Is that direct variation? Yes. And what is the constant of variation? Negative 2. Okay? All right. Graph the direct variation equation. This is the second thing you're going to have to do on your homework. Always start, highlight this, always start with the point 0, 0, because all direct variation equations go through the origin. Always start with that point. And then use the slope to get the second point. Okay? So this says always start with the point 0, 0. So I'm going to put a point at 0, 0. That's my first point, and it's on that line because it's a direct variation equation. Then I use the slope, which is a rise of 2 and a run of 5. A rise of 2 and a run of 5.
I'm gonna eat lunch first, because next room is locked.
I know it is. You might have to sit in the hall or sit on the couch. You can eat. Just, oh, you got to go get it?
Yeah.
Okay. All right. So maybe you did this already. From this point, I went up 2 and over 5. And so what if I go off the graph? I'm just going to make a point there. Up 2 over 5. There we go. Boom. Done. Up 2 over 5. This one here, you start at the origin. That's a point on that line. I'm going to rewrite this, and I'm just going to assign the negative to the 1. You can give it to either the 1 or the 2. It doesn't matter. So now my rise is negative 1, and my run is positive 2. So I'm going to go down 1 and over 2, and here's my other point. Nice negative, right? Nice negative. Cool? Okay, so these two things. Now we're going to apply some of this stuff. Graph the direct variation equation that goes through these points. Now remember, here's the general equation for direct variation. And this is just the slope. It's a slope. So let's plot these points. 0, 0, over 2, up 3. 0, 0, 2, 3. Connect them. To write the equation, what do I need? I need the slope. I need this a in order to write the equation. So I can use the rise of 3 and the run of 2. I need to find the slope. So I can do rise over run. And that is 3 over 2. Correct? Or you could think of it as the change in y over the change in x. You could think of it like that. 0 minus 3 over 0 minus 2, which is negative 3 over negative 2, which is 3/2. Same thing. Either way, use your graph and count, or do change in y over change in x. Doesn't matter. Now you write your equation. So you found a, and you plug that in for the equation. That's it. All right, find the value of a when x is 14. Okay, so here's my equation. I got to plug 14 in for x. 3/2 times 14. So if I do 14 over 1, 3 times 14 is 42 over 2 times 1, which is 2. What's that equal? 42 divided by 2. Anybody know? So it equals 21. All right, so this is the third thing you'll have to practice on your homework. Coming up with the equation either from the graph or from 2 points. Okay? Not bad so far? Doable? All right. If asked to write a direct variation equation, I want you to highlight this whole thing. If asked to write a direct variation equation, you need to find the a in y equals a of x, which is what we just did here. So use the numbers given and solve for a, then write your equation with the number you found for a. Sounds confusing, but it's not too bad. Here's a direct variation equation, y equals ax. You need a. They said write the direct variation equation when y is 6 and x is 3. So I'm going to plug in 6 for y and 3 for x. I need to find a to write the equation. I need a. Can I get a with what they gave me? Yeah. Divide the top and the bottom by, or both sides by 3, and a equals 2, correct? Once I have a, I can write the equation. Y equals 2x. That is what my answer would be. You have to find a, and then plug it in. All right? So you have to do this too. Isn't it pretty? All right, now I really need you to focus. These last two things are kind of applying this stuff. An object that weighs 100 pounds on Earth would weigh just 6 pounds on Pluto. That's cool. Can you imagine? I feel kind of cool. Assume that the weight P on Pluto, oh, this is important. The weight P varies directly with the weight E on Earth. That means this. Y varies directly with X. P varies directly with E. P varies directly with E. This is E, and this is P. They gave me the weight on Earth, and they gave me the weight on Pluto. Weight on Earth, weight on Pluto. P varies directly with E. Direct variation equation. I got to write an equation. In order to write the equation, I have to find what letter here? A. I can do that because they gave me the numbers that I can substitute in. If I think this, and I plug in the numbers they gave me here, 6 and 100, can I solve for A? Yes. Divide both sides by 100.
The other way around.
Uh-uh.
So it'd be 100 equals 6A.
Mm-mm. P varies directly with E, so you have to write it like this, just like this. Y varies directly with X. P varies directly with E, because they said that right here. So my A is 6 over 100. I don't even care if you don't reduce it. Could be reduced. So now I can write my equation. I'm going to take this and put it in for that. And write P equals 6/100ths of E. There's my equation. All right, what would a boulder weighing 750 pounds on Earth weigh on Pluto? Is this E or P? E. So I'm going to use my equation and substitute in 750 for E to find out how much it would weigh on Pluto. Just put this over 1. When you multiply straight across, you get 4,500 over 100, and that equals 45 pounds. That's kind of cool. Something that weighs 750 pounds on Earth only weighs 45 pounds on Jupiter. Okay? Pluto. Pluto. All right. So this now is completely different. This is the 5th thing you'll have to do. Still direct variation. It says that C varies directly with D. So I'm going to have C equals A times D. I need to figure out what A would be. Here's what you do for this. Check to see that the constant of variation is the same for each set of numbers. That means you do Y divided by X or C divided by D. Here. This is my X, this is my Y. Input, output. So if I do Y divided by X for each of these, I'm going to get the same number if it is direct variation. I'm just going to tell you what that is. This is equal to 859. I know I'm writing it small. 859. When I divide 25 by 3. When I do 5154 divided by 6, guess what I get? 859. Oh my word. And then the last one, if I do 7731 divided by 9, I'm going to get 859. These are the same. That means it is direct variation. A equals 859. So this would be a yes, because I divide C by D and I get the same number. So it's direct variation. Each time I divide. I need the direct variation equation for C varying directly with D. All I do is plug in this number, 8.59D. Plug in the A.